Okay, guys, recording officially started. Let's get going. Okay, so we didn't start any of this yet. We didn't start learning Unit 2, so let's get going with some basic ideas in the beginning. Again, guys, many of this will be stuff we've already seen. So I think we've defined equations already, if you guys remember that. Okay, guys in the back, if you want to talk, it's okay, but try and be a bit quieter because I can hear you here. Okay, so anyway, as I was saying, we defined equations the last time. If you forgot that, just check up with Learning Unit 1. But in a nutshell, an equation is just a combination of numbers, variables, and symbols such as multiplication and division, addition, subtraction. Anything which is any combination of those things is an expression. Once you have an equals to signs compare two different expressions. So do you guys want an example? Okay, all right. So we'll just make up an example here. For example, 2x plus 3 over 5, that's an expression, right? If I say equals to 5x, for example, now these are both expressions. This on the left-hand side is an expression, this on the right-hand side is an expression. All together, this forms an equation. And equations just compare expressions. Okay, all right. I think that distinction is made clear in Learning Unit 1, if you guys forget what it is. Okay, let me just leave that there. Variables and coefficients, again, two terms we have to know. So a variable is just a letter used to represent a number which could be changing. It's as simple as that. So usually we use X, Y, Z, things like this. So X is the most commonly used one. So X is the most commonly used variable, and a coefficient is usually a number multiplied by a variable. So for example, if I have 5x, 5 is the coefficient. Okay, all right. Simple stuff, you guys might have seen this before. If not, it's easy to remember. Okay, again, we have to go through a few unnecessary things here, but we'll go through them very quickly. Addition property of equality is just saying that if you have an equation, we represent it by A is equal to B. Very simple equation. Again, you guys know this already. I'm going to cover a few things here in one go. Anything you do to the left-hand side, you must do to the right-hand side. So for example, if you want to add A to the left, if you want to add C to the left, you must add C to the right. That's all it's saying here. Similar with subtraction, you want to subtract C from the left, you subtract it from the right. Same with multiplication and division, right? It works for all these things. Just one more example. If I multiply, I don't know, gamma on the left, I must multiply gamma on the right. So just a simple idea. Whatever you do on the left, you do on the right. Okay. Gamma is just it's a Greek letter used to represent a number or a variable or something. Okay, so quick example at the top here. Solve x minus 6 is equal to 8. Using the principle we just learned, what we need to do when we see something like this is try and isolate x, get it alone on one side. And to do that, we can see if we add 6 to both sides, we will achieve that. Right? Add 6 to both sides. Okay, guys in the back, please. It's early in the morning to be shouting over you guys. X minus 6, I'm just going to add 6 to both sides. So plus 6 is equal to 8 plus 6. Right? See, all I did is add 6 to both sides. And on the left, the minus 6 and positive 6 cancel out. We're left with x. And on this side, we have 8 plus 6, which is just 14. Okay. Some of you guys might prefer to just, I think you might have learned it as move this to that side and make it positive, right? It's equivalent. It does the same thing. So if you use that method, that's perfectly fine. In fact, it's quicker. So let's do that as another option very quickly. You can write this as x is equal to 8 plus 6. So we move the 6 to the other side and change the sign. Okay, and you get the same result. X is equal to 14. Okay, you guys can try this other one at home. Or does anyone want to try it now? At home, okay, perfect. Try it at home. Okay, let's see how much of these we can skip here. There's a few here. Okay, sure, there's a lot here. Okay, I'm just sorry guys, for those who get confused by these, I'm just going to do a few so we have an idea. If it's easy for you, you can just skip through it. Yeah, you can sleep if you want to in the meantime. This will be quick, right? I'm going to do this quickly. Okay, so 3x is equal to 24. What we need to do here is get rid of the x on the left. Sorry, get rid of the 3 on the left-hand side. Once you get rid of the 3, you left only x. So to get rid of the 3, we divide by 3 on both sides. Right, simple as that. Then the 3 on the top cancels the 3 at the bottom and left x on that side. Okay. 3 goes into 24, 12, 8, 8, 16, 24. Yeah, thank you. 8. Okay. Right. You guys okay with that?
Yes, sir.
Okay, we're doing this quickly.
Sir.
Yes, question. Or just agreeing with. Okay, perfect. Okay, perfect. Thank you. All right. So now we have half x is equal to 8, which you can write as x over 2 is equal to 8. Again, doesn't matter. It just looks better that way. Looks easier somehow. Now what we can do here is multiply both sides by 2. That's what we can do here. Right, so if we multiply both sides by 2, we have a 2 on this side, we have a 2 on that side. On the left, the 2's cancel out, the 2 and the 2, and we're left with an x. And on the right-hand side, we just have an 8 times 2, which is 16. Okay, again, very simple stuff. If anyone needs me to stop or slow down, just let me know. Just interrupt me. Okay. Yes.
Divided by 2.
Dividing by 2 because why are we dividing by 2? I mean, you could write it like this, half x. You could leave it like that if you wanted to. Some people do that. You could leave it like that. And now it's still the same idea. We multiply by 2 on both sides. The 2 comes from the question. Okay, it's fine. It's fine. Okay. All right. So we okay. So many of you guys, most people I see like this one here because most people, when they see these things, they just cross multiply. Right? That's usually the easiest thing to do here. You could do a few other things, but anyway, cross multiplication. I'm going to give you guys 2 methods here. 2 methods. Cross multiplication is the easiest one. Let me just rewrite the question here. Oops, that's equals to x over 10. Cross multiply means we multiply the 10 by 7 and then the 2 by x. So negative 7 times 10. Let me just write it here first. Negative 7 times 10 is equal to x times 2. On this side, we get negative 70. On this side, we get 2x. Okay, some people prefer to write it the other way, which is fine. 2x is equal to negative 70. Right, these two are same thing, doesn't matter, right? Looks nicer with the x on that side. Then we divide by 2 on both sides. So let me just show that step. Divide by 2. The 2's cancel on the left. On this side, we get negative 35. Okay, that's one way to do it. The other way would be to get a common denominator and just cancel the denominators out. Right, so yeah, so some people prefer that one. So I'm just going to go over it very quickly. If you don't like this one, it's okay. Right, it's all right. So the left, I write it as negative 7 over 2. We can multiply the top and the bottom by 5. 5, because multiplying by 5 over 5 is the same as multiplying by 1. So it's as if we did nothing. So it's mathematically legal to do that. Here we have x over 10. Now the left-hand side becomes, let's simplify this. We get a 10 at the bottom. Negative 7 times 5 will give us negative 35. Negative 35 is equal to x over 10. And then we can just multiply both sides by 10 at this point. Multiply by 10. So the 10's at the bottom and 10's at the top cancel out. So then we're just left with negative 35 is equal to x, or x is negative 35. Again, 2 methods, whichever one you prefer, you can use that one. Okay, am I going too fast for anybody? Am I going too slow for anybody? Okay, perfect. All right, we found the middle ground. Okay, these you guys can try at home. Let me just see if we can, anything worth doing. You guys think you can manage this example here on the board? You guys want to try it? Okay, I'll give you guys a minute or two. What's the food list going around? Yeah. Okay, you guys are gonna have? Yes. Answer? Okay. Anyone needs help? Okay. Okay, so that's good. You guys can try this other one at home. Let's see if we can get to something more interesting. Okay, distributive property. You guys might have seen this. It's actually we covered this already. I think learning unit 1. It was the spoil idea, right? So we can just let me just go straight to the more difficult example. Just do the last one, because you guys seem to be ahead of everything. You guys think you can do this example here on the board? Okay, give it a try. If you struggle, I'll help you guys. You guys are gaslighting me. Everything's easy, then suddenly it's hard. Okay, guys, anyone finding this one a little bit challenging?
Yes.
It is, okay. All right, that's good because we're doing easy stuff all the time. Now we can learn something new. Okay, so I'm going to do this one quickly. There are many ways to do something like this. So for me, the simplest way would be to open up the brackets on the left. That's the first thing we can do. All right, so doing that, this will become a half times 2 plus a half times a. And on this side, we can write 3a plus 4 over, let's just simplify that to 9 one time. And let me zoom in a bit because I might need to make more space. Okay, so on the extreme left-hand side, the half and the 2 cancel out and we're left with just 1. Okay, half a is just a over 2. And let me just rewrite this side as it is, 3a plus 4 over 9. Now, it's probably best to get rid of the 9 from the right-hand side so we can multiply by 9 on both sides. So let's just make a note of what we're doing, multiply by 9 on both sides. So this becomes 9, not a, it's 1 plus a over 2. And on this side, we multiply by 9. So the 9s cancel out and we're left with 3a plus 4. Let me make my a's clearly distinguishable from the 9s. Okay, so on the right-hand side, the 9 cancels out because we multiply by 9 here. That 9 was cancelled with this, and that just disappears. Right, that's what happens there. So now the left-hand side, we can just multiply the 9 into the brackets. This becomes 9 plus 9a over 2. The right-hand side, we have 3a plus 4. Let me just think for a second if this is fine. 9a over 2. Okay, looks fine to me. Yeah. All right. Everyone with me so far? Okay. Again, some people might have just from here written this as 2a, 2 plus a over 2, and then cross multiplied. That's perfectly valid as well. Okay. Yeah.
Why didn't you plan to by this one and I don't know how they did over school. Because it's not in brackets anymore. But it wasn't in brackets.
It wasn't, but when I multiply by 9, if you do something like that, you have to multiply by the entire thing. Yeah. Yes. No, not yet. Not yet. Okay. So good point. We need to go on from here. So from here, we get the 9s alone. Sorry, we get the a alone to one side. So on this side, we have a 9a over 2. We'll bring the other a to this side and make it negative 3a. On the right hand side, we have a 4, and we'll take the other 9 to that side and make it -9. Okay. So just check from here to here when you guys are okay. I'll just move things around. And remember, when you move something to the other side, you just change its sign in front. The 9a/2 was on the left hand side anyway, so that stays as it is. The 3a must come to this side, so it becomes -3. Right, that's what happened there. On this side, there was a 4, which is fine. We have a 4 there. This must now come to that side, so it becomes -9. Okay, so we're just moving things around. So now I think we have to find a common denominator here on the left hand side, because 9a/2 minus 3a, we don't know what to do with that. So this is technically 3a/1. If it's not shown, we always know that there's a 1 there at the bottom, right? So now let me write it like this. Try and make use of whatever space I have. 9a/2 minus, I'll say 1 times 2, 9a times 2. I'll just multiply the top and the bottom by 2 because again, 2/2 is just 1. It's as if I did nothing. So we can't do that. And here we have 4 minus 9. Let's do that one time. That's -5. Okay. So now the left-hand side, we continue here. This is the only problematic side. 9a/2 minus 9a times 2 will give me 18a. And at the bottom, we just have 2. Okay. Yes. Oh, there was a 3 there. Oh, sorry. Okay. 3a times 2. Sorry. It should have been 3a times 2. Let me just redo that. Okay, thank you. 3a. All right. So then we got a 6 on top. Okay, that's even better. Okay. Sorry about that, guys. Did I lose anybody there? Guys, okay. I know these things can be a bit involved. We just need to practice with a few to get used to them. Okay, guys, the back, please. Okay, -5. So now the top is just a simple case of 9 minus 6. The a there is still, of course, there. So 9 minus 6 is going to give us, I'm going to lose my head just now. 9 minus 6 will just give us 3a/2. And here we still have a -5. Let's write that 2 a bit better. This thing is malfunctioning. Okay. 2. Now, do you guys have any idea what to do from here? So what the easiest thing to do here would be to multiply by the reciprocal of what we don't want here. We don't want this 3/2. So we multiply by 2/3 on both sides. So then it cancels out. Right? So we multiply both sides by 2/3. 2/3. So let me bring this up here. So the left-hand side, the 2 and the 2 cancel, the 3 and 3 cancel, we're left with a. The right-hand side is, why does this keep happening? The right-hand side is just -5 times 2/3, which is just -10/3. So again, these are a bit involved. We might need to practice a bit with them. Yes. Yeah. Yes. At the very beginning, up here. Yeah. Well, move the 9 that side.
Why did you compare that?
Okay, that's a good question. So the reason I did that is because it's nice to try to get rid of the denominators if we can. So 9 is the denominator, so we don't like it. So we multiply both sides by 9 to get rid of all denominators. Yeah, okay. Yes. Yeah. Multiply by 2.
Yeah.
You see that person, there's many ways to do this. We could have done that. If we multiply everything by 2, so we become 2 plus 8 is equal to 2 times this, but then the 9 is still there.
What I think is, like at the bottom, you said 9 times that.
Yeah.
So then that other equation, 3a plus 4, why didn't you do 2 times 3a plus 2? So it's like a cross multiply.
2 times this.
Yeah.
Yeah, where would that 2 come from, bro?
And then the denominator.
Yeah. Because it's not a consistent two throughout, because there's no two here. But if this was all divided by two, then we can do that. Right? So yeah, that's a good question. Alright. But what I'd recommend you guys to do is try different methods if you want to and see if you get the same answer. Right? This one's too long. I think all others might be a bit longer. Can anyone think of a quicker method to do this?
Yeah.
What's that? You got it down? You want me to look at it? Okay, let's have a look. Okay, just bear with me, guys. Have a look at a quicker method. Okay, guys, anyone else just cross multiplied and simplified? You did it well, and it was quicker than this. Okay, all right. So if you guys want, you can try that. You guys want me to do that on the board as well? His method, cross multiply. Okay, all right. So this is one option. Make space somewhere. Let me just do it above here. Okay, so cross multiply, you just write this as 2 plus a over 2 is equal to 3a plus 4 over 9. And then you just cross multiply. Similar to what happened earlier, we take the 9 to the other side. 9, 2 plus a. 2 plus a, yeah. And then here we have 2, 3a plus 4. Right, that's the cross multiplication part. All right, then we can just open brackets up. So here we have 18 plus 9a. And here we have 6a plus 8. And then we just keep, yeah, maybe this is simpler.
Yeah.
Maybe this is simpler, yeah?
Yeah.
Okay. All right. So that works out better, yeah. That's the quicker one. Okay, so then here we'll just have 9a minus 6a is equal to 8 minus 18, and we can see it's going to be the same thing. 3a is equal to minus 10, or a is equal to minus 10 over 3. All right. Yeah. Okay, thank you guys for doing that one. Okay, I'll leave that for a few seconds if you guys are taking it down. Let's see. Actually, it's 8:44, so maybe we should take a break here. You guys need a break?
Yes.
Yes. Okay. 15 minutes. Stop the recording.